And now we can move to the actual research or other research projects. So we have two research projects, which are not the fellowship, but research projects that we have requested and then collaborated with. In that first case, we have Pedro. Pedro is from Brazil and working a lot on peering. And he is working with us on a project called the benefits of peering. And he's mostly focusing on the performance and network aspects of peering. So over to you, Pedro.
Okay, so thank you, Enrich, for the introduction. So I hope that my audio is good because I'm participating in another conference at this moment. But here I will present IXPert, a platform to analyze the network benefits of connecting to IXPs. This is a joint work with some of my students, Enrich, Inácio, and Guillermo from LACNIC. And okay, the motivation of our work that traffic deliver performance resiliency are fundamental aspects of the internet operations today, because we have increasing traffic volumes, we have diverse application requirements regarding latency and packet loss. And the way that the network operators handle those situations is by doing routing and improving their interconnection. And IXPs are essential elements in this process. We have like hundreds of IXPs across the globe. And the challenge here is that each one will offer different opportunities to improve routing and traffic delivery. So one key point that they need to evaluate is that what would be the network benefits of connecting to a given IXP. But estimating these benefits is not a trivial task, because we need to handle multiple data sets that are captured and stored and made available for us at different granularities. And to use each of those data sets, we need to learn a different API to get the data. And also, even though we do all of these previous steps, it's hard to get insightful information from that data. So what we are proposing here is a platform called IXPert, and the name was proposed by one of my students, that is Joaquin. And it's a platform to analyze the benefits of each IXP. And we envision that this platform could be good for network operators, IXP managers, and also the people from the regional internet registers, such as LACNIC and RIPE, for example. Here to illustrate what we are doing with the platform, I will present some possible use case of the platform. The first one is a scenario where an AES needs to find better connectivity to a given AES or prefix. And one way that the AES, the operator, can benefit from that is that it can type the number of the AES that is interested in finding, in this case, the 1916. And the platform will show the list of all the IXPs where that AES is connected, including some statistics about that AES as a member or it's reachable, the number of prefixes, the number of AESs and prefixes on the cone of the AES, and also the address space of the AES that is announced at the IXP, and the address space of the cone of that AES. Also, we can do a similar analysis for the prefix, but in that case, we'll have also the location where we can find the prefix, the AES that is announcing the prefix at that given location, and also the AES path. So that will like help the operator make the decision of, or to identify the shortest path, for example, to reach that prefix. The second use case, when an AES needs to understand if it's good or not to connect to a new IXP. And for that case, the network operator will select one of the IXPs, the IXP of interest, for example, and we will upload its routing table to the platform. And then we will present a series of comparisons regarding number of AESs, number of prefix being announced, or in the address space at the IXP routing table and at the AES routing table, And then we have statistics comparing what we can get in each of them, and also the intersection. For the ASs that are present both at the IXP and in our routing table, we also compare the address space that is being announced by the AS. We can check if the address space is the same or if it's larger in one of the locations. We do the same comparing the length of the prefix that are present in a routing table and at the IXP, again showing the number of prefix that we see in both locations, plus if it's shorter in one place or the other, or if the AS path length is the same. And finally, we have a metric where we compute if the path is redundant or not. For example, because maybe we are getting the same a different something that seems a different routes, but in fact it's more or less the same route. So we compare if routes are similar or not. And the third use case is that it's the case for an IXP manager that wants to compare the benefits of two IXPs. So in this case, it's similar to the previous analysis, but instead of comparing one IXP against the routing table of the AS, we are comparing two IXPs. The analyses are similar regarding members, prefix, and address space. We also have some statistics regarding the reachability of those IXPs regarding their country, for example, also in terms of ASs, reachable ASs, and address space. And then we have the individual numbers plus the intersection with the exclusive parts. We do the same for the prefix. We also have the same for redundancy. And here we also compare like the distribution of the number of hops to reach the ASs in both IXPs. And we also do the same for the prefix. So we can understand, for example, if ASs are closer to the IXP or they're far away from the IXP, and the same for the prefixes. What we are planning to do next, we are adding new features to our platform. Right now, we are adding data plane measurement, get the latency to reach each AS or prefix, because right now we only have data from the control plane. We also we are also planning to do a longitudinal analysis because we are only showing our latest snapshot in the results that I presented to you. And there is also an API that we are developing so other researchers or the network operators can just use the API to get the data and use as input for other streams, for example. And in the case that there is someone from an IXP or a network operator watching this presentation, if we want somehow to collaborate by offering data or vantage points or just feedback, please get in touch with me. I also would like to thank Enrich for the funding, because this was a project that ISOC was kind of starting and we were doing, then we decided to merge forces to do this. So thank you.
Thank you very much, Pedro. I think we might have a question. So I see Ebrima. Ebrima, I'll give you the mic now.
Hello.
Yes, we can hear you.
Hello, Marco. Nice presentation. I just want to know what are the metrics you're using to determine if a path is redundant?
Yeah, so basically we are checking if the similarity of both paths discarding the prefix originator.
Okay.
So
And
it's the number of it's the fraction of ASs that are different from one path to the other.
Okay.
Excluding the originator of the prefix.
Okay. Okay. Nice work. Thank you.
Thanks, Ebrima. Do we have another question? Where can we access IXPert on the internet?
it's not yet publicly available. We are working on that, but I hope that it will be soon. And then probably ISOC will like release the platform and say to people where they can access it.
Right, indeed. So on the Internet Society Pulse, at the moment, we have, I would say, a first version of a tracker that, like IXPert, we call it the IXP tracker, by the way, where we give very basic information about IXPs and also growth over time in terms of capacity and membership. But we are really looking forward to incorporating this work into the IXP tracker, and hopefully we will be able to provide more in-depth analysis and data to operators who wish to peer, so that they can actually use this information to make informed decisions about peering. And it will tie also with our work on the economics of peering, so estimating the economic benefits of peering. On one hand, we have the networking benefits of peering in terms of latency, redundancy, and the number of hops, but on the other side, we also need to know the economic side of things. Excellent. Then last but not least, we have Nowmay, who kindly accepted to join us a bit last minute, but we're happy to have you here. He is helping us on a project studying the state of the internet in Kazakhstan, which we are still working on, by the way, and hopefully soon this will be released. And today he will take us a little bit about the methodologies he has used to achieve this work. Over to you, Nowmay.
Okay, so do you see my screen well? Do you hear me properly?
Yes.
Yeah. Okay. And do you see the PowerPoint? I'm just checking because.
Yeah.
Okay, great. So yeah, let's start. So my name is Nowmay Opalinski. I'm working for a consultancy called Cassini, and I'm also a PhD candidate at the Paris 8 University in France. So basically what I will be presenting today is mostly the methodology we used for this Kazakhstan report. And I'm going to advocate for interdisciplinary research on internet connectivity, because I'm from geography, I'm a geographer, I come from social science, and I'm working along, so Amrish also and other computer scientists, to try to make sense of connectivity from both technical and social aspects. So just to introduce the projects I'm part of, so GEOD is a research project which is funded by the European Research Council. And we are working both with computer scientists and social scientists on trying to map the internet routes, mostly related to BGP traffic, and understand how the internet routes are being impacted by social political factors and also geopolitical conflicts. So I'm going to introduce the network measurements we use, and also why qualitative interviews on the field, like actually talking to ISPs, or at least doing open source investigation, helps to better understand the connectivity choices of the networking actors. If you want to check out the previous publications from my lab, please look at these different publications. We published a paper on the resiliency of internet access in Pakistan in 2024 at INTech. And then we have other papers related to the crisis in Ukraine, and also related to internet control in Iran. So what did we try to look at with the team we had? So Amrish led the team, and Romain Fontugne and Kevin Vermeulen also joined the team on the Kazakhstan internet connectivity. We tried to understand if Kazakhstan internet is resilient, how does it connect to the global internet, does it have any strategic dependencies, how does its social political context impact the shape of its network, and how the current geopolitical frictions in the region impact Kazakhstan access to the internet. So basically, from a geographical standpoint, we try to map the different layers of the networks to better understand how a country is connected, and how are the dynamics of traffic within a region, and on which network is it dependent. So if we look at Kazakhstan, we try to first map the physical features of the network. That's data basically that we collect from the ITU's terrestrial broadband map, and also for submarine cable connectivity, you have telegeography, so it gives a picture of how a country is connected. For example, for Kazakhstan, we've seen that Kazakhstan has mostly connections to Russia. It's a landlocked country, but it also has a few connections with its other neighbors in Central Asia and China, and it's trying to develop also connectivity through the Caspian Sea. So each country has different geographical features which impact how it can connect to the global internet. So it's very important to first have an idea of the terrestrial connectivity within one country, and to understand which ISPs own which infrastructure also. And then we are also using tools coming from BGP monitoring platforms to better map the global network at the BGP level. So we have a platform called Crystal, which enables us to basically collect BGP announcement from all over the world using RIPE Atlas data arrays and route views. And then what we do is that we apply visualization algorithms such as Force Atlas 2 and others to this data to have a graph of connectivity. And so it enables us to have some kind of a spatial analysis of the network. So that was a snapshot taken by my colleague Louis Pétignot of the global network in 2018. And so once we have this snapshot of the global network, we basically select the regions of interest of our study, and then we see how a country is connected. So that was done for 2021 by my colleagues to see how Central Asia is connected. So it's interesting to see that basically all of these countries are really well connected with mostly Russian ISPs, ASs, but also with other ASs in Europe. And it also shows that these countries that do not have many direct links between each other, but they have to go through other maybe tier providers to connect to each other. What is interesting also to see is that some countries are relying on Kazakhstan for their international connectivity, especially Kyrgyzstan. So the visualization algorithm here works in such a way that a node is spatialized within the graph according to the number of links it has with the other nodes. And the bigger the link, the bigger the node, the more links it has with the other nodes within the network. So it's in-betweenness centrality metric we use. And after, when looking at Kazakhstan using the same tools, we can see that Kazakhstan has quite a centralized network structure with 4 main providers giving access to the global internet. So having this kind of visualization help us also to measure network concentration. And as if a network has only a few nodes concentrated most of the BGP agreements, it creates an issue if these networks go down. So that's basically how we can understand geographically connectivity from a BGP standpoint. But then once you know this, for example, you have identified 4 major networks in one country, then it's important to also do some kind of open source investigation or on the field qualitative interviews to better understand, who are managing these networks, what are the interests, so you better understand these ISPs connectivity choices. For instance, for Kazakhstan, we have seen that most of the major ISPs are owned by people from Kazakhstan. Some of them are also partly owned by international providers, and then it helps you to understand the connectivity choices. So that's basically what we did there. And then how to complement this approach with other mapping tools. We have mostly used passive network measurements and all in qualitative investigations, but we can also use active network measurements such as trace routes, especially to understand and to map the actual routes taken by data within the network. There are also other tools developed, for example, by Romain Fontune, which is basically trying to gauge AES hegemony, so trying to understand how an AES is important within a network and how much traffic is going through this AES. Using this kind of active measurements also can help to locate the contents of interest. There were some very interesting presentation about that topic today. So yeah, we can complement this kind of research with other great platforms such as the Internet Health Report, ISOC Pulse Resilience Metrics, and Internet Yellow Pages. So that's mostly what I wanted to present today, trying to understand, how social scientists can work with computer scientists on these topics. So yeah, if you want to get in touch with me, do not hesitate. Thank you so much.
Thank you, Nowmay. I must admit that it has been extremely interesting, and I've learned a lot collaborating with you. And we would like to encourage this type of collaboration with the Internet Society, where not only we want to look at how the internet is functioning, but we want to understand it from a different angle, whether it is geopolitics, social or economic angles. This is what we want to bring together in this fellowship program. So if you have skills in other fields, feel free, and you're actually very welcome to submit an application.